right. So what is marketing mix modeling? Why do we do marketing mix modeling? So first of all, this is generally this marketing mix modeling. First of all, this is an area that has been around for many, many years. So I would even venture to say the idea of doing marketing mix modeling goes back to early 20th century. So it's been around for many, many years, especially before all these newer methods of multi-touch attribution, were invented in the last 20 years or so. This was the core engine for understanding how your marketing, in a way, activities are working. So the kind of problems that this marketing mix modeling tries to address is, you might have heard this adage about marketing and advertising in general, that, I know half of my money that I spend on marketing is lost. I just don't know which half. So marketing mix is trying to answer that question. So it tries to understand, when you're, spending money on different channels, on different activities, and even different creatives and different strategies. And depending on the granularity of the model and different tactics, what portion of them actually, which one of them are actually working, which one of them are not. So in the end, it tries to estimate the true, ROI or ROAS, which is really a hard problem to do, and I'll talk about why that is. Ultimately, when you build these media mix models, you try to answer three main questions. So if you look at the past of all the activities you spend on, you can do a measurement of what actually worked, what didn't, and what is the true ROI of each of the activities that you did in the past. So that's a measurement problem. The second problem tries to solve for is the prediction problem. Now that you've built this model, can you predict for me if in the upcoming campaign or the period that is in front of me, if I'm spending this much on Google and another on this particular tactic, and if I'm spending on Facebook and I'm spending on TikTok or whatever channel that you've been modeling, as a matter of fact, can you predict for me how the marketing is going to perform? And the prediction is actually a little bit different from the problem of in a way forecasting, because forecasting requires detailed information about external effects that you may not have at that point, but try to predict the effect of marketing in the future. So that's the prediction problem. And then the core of the prediction problem is that you can optimize. Now that I know how these campaigns are going to work, or I'm predicting them to work, how I can optimize. So what I would be spending more money on. And the optimization is really, you can think of it in the most simplistic way. If you can do a good measurement of your media activities and media channels in the past, let's say if you're estimated the true ROI of one channel to be 3 and another one to be 0.9, so you know that you want to move money towards the one that has ROI of 3 and move away from the one that you measure to be, let's say, 0.9. And of course, subject to diminishing return, all the complexities, interaction with the channels. We'll talk about some of those, but at its core, that's what it tries to do. And so you might be asking, why do we do marketing mix modeling? We have all these ways of doing user journeys, and go granular user level, some of the things that we normally do at the MTA field, which Madan is really the expert in that area, has been talking about it, and I think the previous class was probably about that. So why do we even do marketing mix modeling? So the reason is that it is the more granular we get, getting the data at that granularity is becoming more difficult, especially with all these privacy regulations that are coming about, and also we are creating silos between different data ecosystems. As we have since actually Facebook came about, and just these walled gardens, and the difficulty of tracking. If I went to Facebook and then I went to, let's say, Amazon to buy something, you really cannot track that journey. It's not possible unless you try to actually to surveil a user to do to see what they do. In reality, you cannot really observe those really interactions between different channels. So, but the nice thing about marketing mix modeling is that the data is aggregated, and You can go at the highly granular level still with these models, but they're not user level, so it's easier to actually get data to build these models. And they also try to be holistic. Instead of trying to just looking at digital channels, you can have mix of offline and online channels. And even within the online world, you can have a good mix of all the activities that you do. So they're trying to be holistic. The data is much more available, if not readily available, to do this. It's really trying to address a key question that everybody is interested in. So with that intro, we go to how we are going to build these marketing mix and media mix models. And you might have actually noticed that I'm actually using marketing and media mix interchangeably. When I talk about marketing mix, it's usually a little bit more expanded model than media mix. So you add, let's say, promotion or pricing and stuff like that, and product features. If you try to add more variables than just the media, then I tend to talk about it as marketing mix. If it just focus on media, it becomes more media mix. But again, at least I use this interchangeably for the most part. And so when you are, so essentially what it does, I talked about this, enables optimizing marketing spend. This is the optimization problem that I talked about in the previous slide, and also help us to get an understanding of relative importance and contribution of different channels to the overall outcome that we are trying to drive, and will allow us to do budget allocation. And again, because the data is aggregated, is much better available than a lot of these other user level data that have become more and more challenging to get. So if I want to go to the next slide. So how are we going to build these models? And I think it was Carl perhaps who's talking about building this regression model. So building regression models is really sits at the core of a lot of, at least traditionally, that's what has been used. Where the explanatory variables are your marketing activities or the impressions. And like, for example, your spend in some cases, and that's your stimulation, that's the input to the model. And what the model tries to do, the target variable or the dependent variable is, let's say the revenue. If you care about revenue, if you care about, in some cases, a lot of clients even don't have a good definition of revenue. They may want it in financials. For example, financial clients, we have this all the time. They want to predict the number of accounts opened, and they may want to get also more granular, the number of accounts open for this segment of the market or that segment of the market, commercial versus, business and so forth and so on. So really that becomes the outcome that you care about, that you want to see how your marketing is driving those outcomes. And there are, basically linear multiple regression models that traditionally used. Usually, applying just linear models are not a good idea. Log linear, I prefer that personally, because it naturally measures the effect, the diminishing return effects. I think Madan was talking about that in the previous lecture. And so it captures some of the nonlinearity. It's also multiplicative in the sense that it just tries to optimize the fit with respect to the relative percentages as opposed to absolute value. So as a kind of an offshoot of this linear multiple regression model, you can think of log linear. So the logarithmic inputs and logarithmic outputs. That's one of my favorite ones if you want to build something more traditional sense. There are other things like Bayesian models that have been used, mixed models. These are also very powerful models because in some cases, and by the way, Mari and I use these kinds of mixed models all the time. And what they do is that they try to really get some of these inputs are, especially if you're getting to the granular level, some of the inputs, let's say if you're running TV campaigns in Northeast and you're running TV campaigns in maybe Mid-Atlantic region. You don't expect for similar demographic, these campaigns are gonna perform very differently. So if you think of these two input streams as completely separate, two different explanatory variables, you may actually miss that well. I mean, they are both TV and they're within similar geographic areas. So these mixed models help us really structure the model much more appropriately based on our understanding of what channels and what areas and what products are expected to behave similarly. So we leverage that kind of models a lot in the past and pretty successfully. There are other models that actually have been used. Random forests seem to, at least at some point, they were like the talk of the town, and everybody was talking about random forests. I mean, they're powerful techniques. Gradient boost machine learning models, they're also pretty good. And also there are, and I'm sure you're following this the last almost a year, maybe even less, the explosion of AI, machine learning models and transformer models that are being used. And some of these models are actually could be pretty powerful. That you can use as basically feed your inputs, your explanatory variables, or in this case, your stimulation variables into it, try to predict the outcomes. One of the drawbacks of some of these models, actually tree-based models like random forest and even gradient boost, they're not that bad, but some of these other black box model you may not be able to get a better understanding of whatever prediction it's making, why it's making that prediction. So they're not very explainable, but maybe you can make them explainable. So but these are some of the things that I would encourage everyone who is interested in this field to at least have them on your radar screens. And at some point you might see actually they're being used much more extensively than in the past. So next slide, please. So there are many challenges into building these media mix models, and the starting from the very simple one, quality of the data. We talked about that, and we'll talk about it a little bit more. It is really the model is based on what you feed into it. So if you some of the relevant factors that you actually are missing or might be influencing the target variable, if you miss that, then you can get very, very bad conclusions out of your model. So you have to be very careful. So some of the effects, which is similar to what the collinearity, but in a little bit differently. Let's say if you don't model the effect of seasonality and in the model, and then you try to build a model without that, then you might be attributing the rise in the sales to just the media, because normally you spend more, if you look at historical data, very often you come across a situation that, at high demand time, people start more, spend more on marketing. And then really that marketing, the increase in the marketing spend is really a proxy for seasonality. And if you don't have the actual seasonality factor in the model, then you might be attributing the rise in the sales to actually your marketing, but it was not so. But your marketing would have had an effect anyways, and how are you going to measure that? So you don't want to underestimate the effect of your marketing. You don't also want to overestimate it. You just want to do it right. So, and if you're not careful about what inputs you're putting in your model, you might actually get a lot of biases as the output. So have to be very careful about that.
Payman, can I just pause for 1 second? So to Carl's question, Carl asked a collinearity question at the top of the lecture. And are you recommending that the learners actually use a seasonality variable as part of the input feature so that it absorbs the seasonal variations much better, and therefore your media gets right credited? Is that the simple answer to managing collinearity, or what do you recommend that folks like Carl actually do?
I would say, that is collinearity, depending on what, basically, it is very likely that Carl, please feel free if that's not what you thought about. But
sure, it
about input. Yeah, go ahead.
Yeah, two things. So one, seasonality speaks to the point of what you were just mentioning, Dr. a minute ago, in terms of making sure you're capturing the appropriate amount of media contribution. So in many cases, the media marketing contribution might be somewhere between, 5 and 50%. In big CPG companies, other offers, all these other things, the media contribution is relatively small, but to your point, seasonality could make that number appear larger. My question about multicollinearity was less about exogenous non-media variables and specifically about competing media variables that are flighted at the same time. I mean,
Yeah.
such as your cable and primetime TV is usually the
Absolutely.
most classic example.
Yeah, absolutely. Yes, that's right. So so basically you're running multiple campaigns simultaneously. It's almost collinear with each other, and it's hard to separate. So there are multiple ways. I mean, there are traditionally the way people address the collinearity and the modeling in general is through approaches such as principal component, try to actually decompose those. But another way that we found to be very useful there, and the mixed models that I talked about in the previous slide is another way of doing that, because it will try to really aggregate data at the right level, and it will be helpful. In some other cases, if the collinearity is so bad, unfortunately, you will not be able to estimate the effect of things separately. So, you need to identify that and make sure that you do some kind of experiments, going forward. So there are multiple ways to address it. One is, again, try to technically decorrelate as much as possible, and and aggregate data at the right level, and so forth and so on. But in the end, if there are and if your period of analysis is relatively short and you're running multiple campaigns very collinearly with each other, unfortunately, there may be no way actually to separate them. So you need to just extend your analysis, or do some experiments to get a better sense of that.
Can I try a summary, Payman? Maybe you can tell me. So 3 things you talked about, right, for addressing collinearity. One is stuff like principal component analysis, which is a statistical method, helps you kind of decorrelate it by creating principal components from the data. Number 1. Number 2 is mixed models. Number 3 is testing. And can you unpack the mixed models for us a little bit? How would you aggregate? What's an example of a mixed model that helps you deal with collinearity? Can you probably give a example of your experience?
Sure. So, in one mixed model, so for example, if you're trying to estimate the effectiveness of, so let's say you have two input signals, being, again, I'll give an example of TV in Boston and TV in, let's say, the DC area or New York. So if you're essentially, you can actually decompose basically when you're parameterizing your model. So you have an effect for, let's say the channel effect, and then you have a geography effect. By doing this, you're reducing the number of free parameters that you are estimating. So instead of doing all kinds of combinations of inputs and outputs or stimulation responses, you would be managing that to an effect, by aggregating the data. And this way, it's not that it will eliminate collinearity, but the chances that you get a collinear effect becomes a little bit lower, because you will have fewer parameters to estimate. So your matrices become a little bit better shaped, or the condition of the matrices become a little bit better, because you do not have a lot of free parameters that you're trying to estimate. So that's one of the approaches, but again, it may not really eliminate the collinearity, but it does a better management of the size of the data you're dealing with, and as an aftermath, it might actually, or as a byproduct rather, it may help you eliminate that. But the standard way, again, going through the statistical model or the principal component and just addressing collinearity, or doing something with respect to the doing the experimentation if you really cannot get rid of that collinearity.
Thank you, Payman. Do you want me to stay on this slide or go to the next one?
Yeah, well, I think there's a couple of things I wanted to mention here. So there are a lot of other challenges involved here. So again, because it's an aggregate model, it may not capture the granular effects very effectively. The proper updating of the model coefficients, there is a delay involved, right? And if the delay is longer, especially if there is a decision cycle that's just not like you see an ad, you go and buy it, then you need to. That makes the model a little bit more challenge. It creates more challenges for the model to not only pick the effect, but also when the data gets updated. If you want to update the model, you need to wait. Let's say you ran a campaign and it takes 3 months for the campaign to show its effectiveness. Then you really need, there are delays involved, right? I mean, you need to, if you want to see run a campaign now, you have to wait at least, let's say 3, maybe even more, longer, 4 or 5 months to just see if the effectiveness is there. And so if you have very long lasting, media, and let's say especially you're building brand and so forth and so on, just using one media mix model that tries to measure from the stimulation to response will have a lot of challenges capturing those longer term effects. So it's another thing. And there are ways that you can actually address that. So for example, for this longer effect of things, I mean, you may want to, instead of just building one end-to-end model from stimulation to the outcome, the last outcome that you care about, let's say conversion or purchasing, you may want to break down your funnel into smaller sections, let's say to brand awareness. And if you have especially KPIs or measures that can help you figure out much faster as a leading indicator, you raise your brand awareness or you improve your engagement with the website and things like that. So if you break down your funnel into sections and then model them separately, because then the delays will be broken into these pieces, and then relate them into some kind of a cascaded model funnel, then you might have easier time measuring those kinds of longer term effects. Otherwise, it will become very, very difficult. So it's another thing to think about as you're building these media mix models.
Payman, is this an answer to second question that Carl asked, which is about lower funnel channels like branded search and SEO, right? SEO is not as much of it, but lower funnel channels like branded search, which kind of act like a response channel, even though it's kind of a media input. Would you say that you would do these cascaded models? Is there a scheme like that? Would you recommend, or how would you say?
Absolutely. Yes, absolutely. So it would be, and to that point, I mean, let's say if you have a lot of awareness, if you have a lot of engagement, those lower funnel channels will be performing much better. I mean, their ROI would go up, but it's not because they are good. I mean, it's also because of that probably, but also that you already have engagement. If you're not taking those things into account, if you build a model, they always win. The upper funnel channels always lose. Almost always, depending on how you model this. But if you break it into pieces, then you may actually conclude that, well, yes, I'm getting a lot of good results from these lower funnel channels, but if I tweak the